Dams shape the world around us. They reimagine vast landscapes by repurposing rivers, and they provide energy to millions of homes across the globe. These monolithic civil engineering wonders have been around since the birth of civilization, and today they are a vital source of electricity. Globally, 16% of the world's electricity is produced through hydroelectric power plants, most of which are located inside, on, or near to dams. At first glance, dams don't appear to have any energy-producing power. To the casual onlooker, they're just large concrete or earthen structures that keep water from flooding areas downstream. However, dams, and more specifically hydroelectric power plants, take advantage of one of Earth's most abundant resources, gravity. Hydroelectric power plants harness the potential energy created by the water that the dam holds back. They capture the energy of the water as it falls from high up behind a dam. This is done through the use of turbine generators, which harness this kinetic energy and transform it into mechanical energy. This mechanical energy is then converted into electrical energy with incredible efficiency. Modern hydropower plants can convert energy from water held by a dam into electricity with up to 95% efficiency, contrasted to the best fossil fuel power plants, which operate around 50% efficiency. Dams and their accompanying hydroelectric plants can range in size from a few feet high, used to power a few homes, to several hundred feet, like the Three Gorges Dam in China that can power entire cities. Now let's learn a little bit more about how these power plants work. Modern hydroelectric plants include four main components. 1. The dam. Dams are used to create potential energy in water, allowing it to build up in great quantities at elevation. Dams are also a way for power plants to store energy and control flow. 2. The turbine. The turbine is the mechanical component that transforms the flow of water through a dam into mechanical energy. Turbines are like windmills, except the forces that spin them come from water rather than wind. 3. The generator. The generator takes the mechanical spinning energy from the turbine and uses it to generate electricity. Generators in hydropower plants work exactly the same as generators used in other situations. 4. The power transmission lines. These take the electricity from the dam and power plant all the way to the houses and other places that need it. Now, let's start thinking about how much energy a dam can make. The ability of a dam to produce a given amount of electricity depends on a few factors: how far the water has to fall, how much water is falling, and the efficiency of the turbines and generators. These three factors are significant when determining the output of a given dam. For example, the farther that water falls through a dam, the more power it has. Gravity acts on the water at the top with an acceleration of 9.81 meters per second squared. The further it has to fall, the faster the water moves when it hits the turbine. The power that water can produce is directly proportional to the height that it falls. Simply put, a 100-foot dam has twice as much energy producing capability as a 50-foot dam. The amount of water falling also has a big impact on the energy producing capability of a dam. While the height the water falls at a given moment impacts how much power it can produce, the amount of water falling at that height impacts how much power is actually produced. The amount of water is often not something humans can control, though, as it is dependent upon how much water is flowing into the lake the dam holds back. Dams and hydroelectric power plants can adjust flow to the turbines, but at the end of the day, they only have as much water to power the plant with as is held in the dam. If dam and hydroelectric power plant operators ever want to speed up or slow down how much electricity they are producing, they can change the flow rate of water they're letting through. In this way, engineers often think of dams as physical batteries. Storing a given amount of water in a dam is essentially creating a battery of water that can be used to generate electricity later on. Lastly, The energy-producing capabilities of dams depend on how efficient their turbines and generators can be. Given that hydroelectric power plants have a roughly 90% efficiency, these power plants are some of the most efficient out there. Now let's recap the basics. Dams are used to block up rivers and streams to create potential energy with the water by holding it in reservoirs at a higher elevation. The dam is then used to control the flow of that water into a hydroelectric power plant, which are often located inside or right next to the dams themselves. That water flows into the turbine, which is spun by the water. The spinning turbine then turns the generator, which transforms the spinning motion into electrical energy. That electricity is then carried through transmission lines to your house,